Front-end development has become nearly instant with AI copilots, but backend development still requires coordinating across backend engineers, DevOps, and site reliability engineers. While AI app builders like Bolt and Lovable promise a full-stack experience, they break down as systems become real. As complexity grows, teams are pushed back onto AWS, GCP, or Azure, where everything becomes manual again. However, recent advances in large language models, particularly Gemini, have fundamentally changed this equation. Gemini 3 models don't just write code, they can run it, verify it, observe failures, and correct themselves in closed loops. This expands what's possible and has led to the idea of Crosswind, a self-building, self-maintaining backend infrastructure platform enabled entirely by Gemini 3. This is the interface. I've created a demo project so users can explore what Crosswind offers. I'll sign in with GitHub. My account is already connected. Crosswind works by connecting directly to a front-end GitHub repo. It detects UI features and changes, then automatically configures the backend and wiring needed to support them. Here, we'll import a repo called clause-frontend. Before importing it, let me show you the repo locally. It's an AI legal workbench with hard-coded project names. Users can create a new project by dragging and dropping legal files. Inside a project, all case files appear in one place, and users can ask questions that an agent answers using cited evidence from those files. Supporting this requires a RAG system, likely Elasticsearch, along with queues, batch processing, and Gemini powering the agent. That's a lot of complexity, so let's import the hard-coded front-end repo into Crosswind. As soon as we import it, Crosswind triggers a code analysis pipeline that generates an architecture blueprint. Under the hood, Code Analysis Agent first scans the front-end for UI elements like buttons and text areas. A contract registry agent then registers these as UI contracts in the database, which are passed to a system designer agent to define the required cloud services, APIs, and databases. Once the pipeline completes, we get a notification to continue with DevOps, which we will. But first, I'll configure our GCP credentials by uploading them here. Since this is a development project, I'm using an owner role, but you shouldn't do that in production. Crosswind automatically checks the service graph and verifies that all required GCP APIs are enabled. With that done, we can continue with DevOps. Clicking this triggers the full DevOps pipeline, which runs for a few minutes. Crosswind generates the entire backend codebase and deploys the required cloud resources. Under the hood, this is handled by a coordinated set of agents, an orchestrator, provisioner, verifier, and remediator. If the provisioner gets stuck, issues are passed to the remediator, which uses grounding search to resolve them. The verifier then actively tests every endpoint and resource and fixes anything that doesn't work, which prevents hallucinated infrastructure and broken deployments.